Now we're going to take those two basic structures that we saw, the anticline and syncline, and add something to it that we're going to call plunge. So what we saw, right, with our rock layers is when we had a force, right, act on it, it's going to cause it to bend. But we saw forces just happening from two directions. Now let's think about it. Does the earth only act from two directions? No. We're going to see a third direction come in. So what's going to happen is it's going to smear out that structure. So again, it's like taking a lump of Play-Doh on your desk and just smearing it out, just stretching it out. So that's all we're going to see, okay, is this third direction of force. So let's take a look at the syncline and anticline and see what it looks like when it plunges. So the first one let's look at is a plunging syncline. Now, I can recognize that it's a syncline by two different ways. One, I see the U structure in cross-section, so I know that it's a syncline. But I can also notice that it's a syncline because I have my older beds on the outside and my younger beds in the middle, telling me it's a syncline. Now I know it's plunging because I see that it is smeared out. Now here's something I want you to note. Even though it's plunging, the cross-section looks the same. It doesn't matter. It doesn't matter if it's plunging or not. The cross-section is always going to look the same. It's only the surface that's going to look stretched out. Okay? So, what I want to do is two things here. Let's add our strike and dips. You'll notice the strike and dips are going to do the same thing. Right? Everything is dipping towards the middle. But we need to give a direction of plunge. We need to explain the plunge. So, like I said, we know that this is a syncline. So let's call it a syncline. But we need to give a direction to the plunge. Now I want you to pay attention to this. We see that it forms those U's on the surface. So we're going to look at the direction of these U's to tell us the direction of plunge. On a syncline, we look at the open end of the U. Whichever way the open end is pointing is the direction of plunge. So here, let's trace out one of these U's. Here we have a U. The open end of the U is pointing down. So that makes this a south plunging syncline. Okay, so just remember that. We look at the open end of the U, and whichever way that's pointing is the direction of plunge. We can have a north pointing, an east pointing, a west pointing. It doesn't matter. Okay, and the cool thing is it's always going to look the same in cross-section. And I'm going to show you some more examples of these here in a few minutes because we're going to do a big cumulative whiteboard and looking at how we're going to draw these structures. Now, let's take a look at the plunging anticline. So here we have a plunging anticline. I know it's an anticline two ways. One, I see the frowny face in cross-section, but I also recognize that my older bed is in the middle and my younger beds are on the outside. So let's draw our strike and dips in here. Right? It's going to be the same as everything else. It's pointing away from the fold axis, just like we've seen. But now let's give our direction of plunge. So you notice again, right, we're going to have our U on the surface. Now, because anticlines and synclines are opposite of each other, for an anticline we look at the closed end of the U. Whichever way the closed end is pointing tells us the direction of plunge. So let's look at one of the U's. Here's a U on the surface. I see that my closed end here is pointing up, so that makes this a north plunging anticline. So again, that U can point south, it can point east, it can point west, it doesn't matter. It's always going to look the same in cross-section. I just got to look and see which way that closed end is pointing to tell me the direction of plunge.